Padma Industries, delivering innovative water and wastewater treatment solutions.
The process begins with a bar screen to remove large debris, followed by an oil skimmer to eliminate floating oils and grease. Water enters the equalization tank to balance flow variations. The dosing system adds necessary chemicals for treatment. In the flocculation tank, particles clump together into flocks which settle in the reaction settling tank. The lamella clarifier efficiently separates solids using inclined plates, ensuring cleaner water. The pH meter monitors water quality. Finally, the aeration tank introduces oxygen to break down organic matter.
In the conventional activated sludge treatment method, sludge is separated into solids and liquid in a settling tank. This is called clarification. The innovative MBR technology combines activated sludge treatment with solid liquid separation by means of microporous membranes, in place of the traditional separation by secondary clarification. The MBR modules can be put in a separated tank after the oxidation tank. This configuration is called standard system. The MBR modules can also be put directly in the oxidation tank. This configuration is called compact system, suitable for non-potable reuse applications. The MBR system can be rearranged in a variety of configurations. The typical MBR system includes a rotary influent screen and anoxic, anaerobic tanks for biological treatment. The MBR modules and MBR tank, air blowers for the aeration process and for membrane scouring, a pump set for the MBR permeate suction and for sludge recirculation, chemical dosing systems, and a cleaning tank for periodic chemical enhanced backwash. The first step of the treatment process is the mechanical screening of incoming wastewater. The screened wastewater flows into the anoxic tank. Within the anoxic tank, a submergible mixer blends the screened wastewater with mixed liquor returning from the MBR tank to achieve the desired level of denitrification. In the absence of dissolved oxygen, nitrate is converted into nitrogen gas in the tank. From the anoxic tank, mixed liquor flows to the anaerobic tank. The anaerobic process triggers the discharge of phosphorus by microbes in the anaerobic state reaction. From the anaerobic tank, the wastewater flows to the aerobic tank, where oxygen is injected using air blowers and a diffused aeration system. In this oxygen-rich environment, organic material and ammoniacal nitrogen are biologically oxidized in the carbon dioxide, nitrate, and water. From the aerobic tank, mixed liquor flows to the MRB membrane tank for liquid-solid separation. The MBR membrane is the heart of the treatment process and offers many advantages over conventional activated sludge processes. Flat sheet MBR membrane modules are fully submerged into the mixed liquor inside the tank for direct outside to inside filtration. The modules are made of robust reinforced flat sheet membrane with a nominal pore size of 0.04 micrometer. The membrane separates solids and microbes from the activated sludge. The module aeration system generates an upward water flow and air flux to prevent membrane fouling. This allows extreme efficiency up to 99% in suspended solids removal, delivering highly treated water suitable for reuse.
Padma's water recycling plant uses reverse osmosis to further treat wastewater after the ultrafiltration process. Reverse osmosis membranes are constructed from a membrane flat sheet. It is comprised of 3 layers: a polyester fabric support base, a microporous polysulfone layer, and a 0.2 micron thick polyamide barrier layer. The polysulfone layer strengthens the very thin barrier layer. It is the barrier layer that removes nutrients, chemicals, bacteria, and viruses from the water. The membrane flat sheet is combined with a sheet of feed channel spacer. This provides turbulence and creates space between the membrane sheets for the feed water. A sheet of permeate spacer is added to the membrane sheets and feed channel spacer. This enables the final recycled water product, or permeate, to flow evenly across the entire membrane surface, even under high pressure. The back of the membrane is completely sealed to the edges of the permeate spacer. The membrane sheets are glued along each of the 3 exposed sides and rolled around the core tube. Feed water is forced through the feed channel spacer and into the barrier layer of the membrane. Water passes through the membrane surface into the permeate channel. It flows in a spiral direction and collects in the core tube. This water is the final recycled water product, or permeate. There are 7 spiral wound elements loaded in one pressure vessel. Once the end adapter is connected to the last element and the pressure vessel is sealed, feed water can be introduced. Feed water is pumped at high pressure into the vessel. As it travels, small molecules like water pass through the membrane, while larger particles such as salt, bacteria, and viruses do not. The final recycled water product is collected from the end of the elements. The concentrate or reject from that vessel flows to another stage, producing more recycled water. At St. Mary's, there are 6 reverse osmosis treatment trains, each with 3 stages. This design produces the highest amount of recycled water with reduced concentrate waste. Stage 1 has 52 pressure vessels, Stage 2 has 24 pressure vessels, and Stage 3 has 12 pressure vessels. 58 million litres of feed water enters the reverse osmosis system on a daily basis. As the feed water passes through each stage, more recycled water is extracted. 65% of recycled water is extracted at Stage 1. The remaining 35% is passed through Stage 2, where a further 10% is extracted. The final 25% is passed through Stage 3, where the last 5% of recycled water is extracted. 80% of all feed water is recovered as recycled water. An average of 50 million litres of recycled water is produced every day at St. Mary's. The remaining concentrate contains so much salt and impurities that to recycle it would not make economic sense. This concentrate stream of 8 million litres a day is sent to North Head Wastewater Treatment Plant, where it is treated and released into the ocean.